Bright Tuty. Every student matters.
Hello dear students, my name is Amit Ajmani and today we will be discussing about the derivation of equations of motions through graphs. In the previous topic, we have studied that there are three equations of motion. Now the important thing is the first equation of motion. This equation of motion is also known as velocity time equation. This is very important now students, because in examination you won't be probably getting first equation of motion word, right? You will be asked that derive velocity time equation. So when we are talking about velocity time equation, indirectly the examiner is asking us about the derivation of first equation of motion, right? Similarly, second equation of motion is also known as position time equation, and the third equation of motion is also known as position velocity equation. So these are the three equations, the names that you need to learn. Sometimes the students get confused as to what is it first or second or third. Please try to write down all the three equations of motion and then try to relate. Fine. How? Now in first equation of motion, we are being given the initial and final velocities and the time. So that is why we called it velocity time equation. Mainly we are being given velocity and time. All the three equations we will not consider acceleration, alright. In the second equation of motion, we have been given primarily time and the distance. So with respect to time, the distance is the object is moving, so its position is changing, and that is why we called it position time equation. Wherever S is given, we will relate it with the word position. In the first equation, S was not there, so position word was not there, right? In the third equation of motion, now we can see that S is here, A we are not considering, so S we will call it position. Velocities are given, so velocity, no T, no time is there, right? Are you trying to relate what I am trying to say? That it is position velocity that is primarily given in this equation, that is why it is called position velocity equation. So I repeat, the first equation in which T time, velocities, it is called velocity time equation. Second equation of motion, S means position, primarily T is given, right? Then position time equation, right? And third is S is given, that is position, and velocities are given, position velocity equation. Got it? Very important. The first equation of motion states that V is equal to U plus AT. The second equation of motion states that S is equal to UT plus half AT square. The third equation of motion states that V square is equal to U square plus 2AS. And we know the meaning of each and every alphabetic representation that we are using here, that small u represents initial velocity in all the three equations of motion, small a represents acceleration, small t represents time, v is used for final velocity, and s is used for distance. Along with this, we also know their standard international units. U and v, they are both velocities to be expressed in meter per second, acceleration is expressed in meter per second square, time is expressed in seconds, and distance is expressed in meters, right? Previously we have just seen from where have we derived these equations of motion, but that was numerically. Today we will be making use of the graphs. Now we have studied about the distance time graph and the velocity time graph. in this particular topic we will be just going through the velocity time graphs in order to derive these three equations of motion. But for that we need to study a few things before that. What? Let us see. When I am talking about any particular graph, in a graph, for example, this is a graph that I have made. Let us take a graph. Now this is a VT graph or the velocity time graph, in which we have taken velocity on the y axis and on the x axis we have taken time. Got it? Now what we do is we take a body whose motion is shown like this in the graph. Previously we have studied that in a VT graph a straight line always represents uniform acceleration. So this is the uniform acceleration shown by this body. Let us give some representation to it. For example, this is the line AB. Now if I take the values in the graph, let us take this is starting from the origin or the 0 part. Time is given to us in, let us say, in seconds. This is 10 seconds. Let us say this is 20 seconds, this is 30 seconds and 40 seconds. The velocity or speed is given in meter per second. Let us take it to be 5 meter per second. This is 10 meter per second, this is 15 meter per second and this is 20 meter per second. Right? Alright. Let us take a body who is travelling with this uniform acceleration from this point A to point B. Right? This point B, on this y axis it corresponds to 20 and on the x axis it corresponds to 40 seconds. Right? Now when this body is travelling under uniform acceleration, we have to calculate the acceleration of this body, and if in a graph we need to calculate the acceleration, then that acceleration can be calculated by, try to remember what I am trying to say, this won't be you won't be finding it in the book, I will relate it later on. Acceleration is given by slope of line AB. AB means that particular line which shows the uniform acceleration. Now when I say I am calculating the slope of this line, there is a formula for calculating it. Right? I am telling you a different way of doing it. Now slope of line AB is calculated by this formula, perpendicular upon base. If I am taking this particular slope as the hypotenuse of a triangle, I have just take this construction, I have just constructed it taking a perpendicular parallel to the y axis and this is my base. So let us give it this name C. So I see that there is a triangle ABC. Now in this triangle ABC we can assume AB to be our hypotenuse, BC to be our perpendicular and AC to be our base. So when I need to calculate acceleration, I will calculate it using the formula slope of line AB, and this is calculated by the formula perpendicular upon base, assuming this to be a triangle. So in this triangle ABC, if I want to calculate it, I will say that acceleration will be equal to BC upon AC, because perpendicular is BC and the base is AC. Now if I want to calculate the BC part, what I will do is I will see where exactly this B point is corresponding. This is corresponding to this particular 20 value. This is 20 meter per second. I will take this as V2. This is the velocity, right? And the initial velocity, let it be V1. So what I will simply do is I will just subtract it. How? V2 minus V1 value. That is the upper end value minus the lower end value. This I will get what exactly is the value of the BC or the velocity, divided by, similarly if I want to calculate the time, the initial time from where the body started, I will just mark it as t1 time, and the value till which we are calculating, that is till c, that will be taken as t2, and if I want to calculate the time difference, then it is given by t2 minus t1. So, taking these values from this graph, what we have found out, what we have calculated is the BC part, this BC is equal to the higher value V2 minus the initial value V1, 20 minus 0, divided by time factor, time I am calculating as T2, which is 40 minus T1, which is 0. This comes out to be 20 upon 40, cancelling it out, I will simply get 1 by 2 or 0.5, and since I am calculating the acceleration, it will be meter per second square, the SI unit, right. Please try to relate once again what we have seen here. Whenever I am trying to calculate acceleration through the graph, I will see first of all where exactly is the body accelerating, right. We will take more examples where we will see different motions. Just taking this particular question right now, the body is showing uniform acceleration starting from A point going towards B point, right, and we have to calculate what exactly is the acceleration of this particular object. So, what we have done is we have just calculated acceleration by using the formula slope of line AB, and it is further calculated as perpendicular upon base. Fine. How perpendicular and base? We need to construct the perpendicular with dotted line, and the base, the perpendicular will be parallel to the y axis. Fine. Let us take one more example in which you will be able to relate it in a better way. Let us see. In this case, now again I will take a VT graph. Let us first of all put up the values. The time is in seconds, the velocity is in meter per second. Let us take 0, this is 5 seconds, 10 seconds, 15 seconds, 20 seconds, 25 second time. Velocity is 10 meter per second, 20 meter per second, 30 meter per second, 40 meter per second, right. Let us now, rather than taking it from the 0 or the origin part, let us take it from this particular part. Fine. Let us see. Now, this is the motion of a car which is represented by AB. Since we see that this is a straight line on a VT graph, therefore, of course, this is a uniform accelerated motion. What will be asked in this question is calculate acceleration. So, if I need to calculate the acceleration, my basic formula remains the same. Initially, I will relate it with slope of line AB. And how I am going to calculate this slope of line? This is calculated by the formula perpendicular upon base. Now, since this line is not starting from the origin, so in order to find out the perpendicular and base, what we will do is we will take the constructed dotted line, perpendicular line, which is perpendicular to x axis or parallel to y axis, and here also I will draw a perpendicular which is on the y axis or parallel to x axis, right. In order to find the base, I will also draw one perpendicular from here which meets this particular dotted line at point C. Now, I can see a triangle getting formed, triangle ABC, in which AB is the hypotenuse, right. I am not talking about the Pythagoras theorem here, please do not get confused. This is simple, a right angle triangle in which AB is the hypotenuse, BC is the perpendicular, AC will be the base, right. So, putting the values in the formula, in perpendicular part I can write according to this triangle. The perpendicular is BC divided by the base is AC. Now, how I am going to calculate BC? Let the velocity at B point be V2 and this is corresponding to 40 and the starting velocity is V1 corresponding to 20. So, the difference or the change in velocity is calculated by V2 minus V1 divided by the change in time. The body is travelling or the car is travelling from A to C. So, the time corresponding to C, that is 25, is going to be taken as T2 and the initial time 0 is taken to be T1 and AC, which corresponds to 0 to 25, is calculated by T2 minus T1. Now, the V2 velocity is 40, the initial velocity is 20. So, therefore, the difference in velocity is 40 minus 20 meter per second divided by time 25 is T2 and T1 is 0. We can see that this BC, this part is equal to this part from 20 to 40. So, to calculate this BC, we will just take the higher value V2 minus lower value V1. Similarly, this time AC part is basically equal to this much part as we can relate, and this is the higher value is 25 minus the lower value T2 minus T1. Clear? So, here we simply get 20 upon 25 or it is 0.8 meter per second square. Unit is important because we are calculating acceleration. So, we will be putting up unit meter per second square. Got it? This is how we have calculated the acceleration when the body is not starting from origin or the 0 point. Let us take one more example to calculate the acceleration. Let us take this particular graph now. This is our VT graph. V is in meter per second, T is in second. Let us put in the values 0, 10, 20, 30, 40. Let it be 5, let it be 10, 15, 20, 25. Correct? Now, let us take the motion in a different way. How? I will start from this particular point, I will take it till here and then from here I will just make a straight line accelerated motion till here, right. So, let the motion be giving the names A, B, C. Now, in this particular graph, if you relate the previous topics, we see that from A to B, it is a straight line which is parallel to the x axis, and in a velocity time graph, this shows constant speed or constant velocity provided the displacement and direction are same, and whenever a body is moving with constant speed, that means the acceleration is taken to be 0, right. So, from A to B, the body is not accelerating. Next, from B to C, we saw that now it is going in the upward direction as a straight line. Therefore, we relate that it is an accelerated motion. Again, we are asked to calculate the acceleration. Now, how we are going to calculate the acceleration? We know that acceleration is calculated with the formula slope of line AB. And how we are going to calculate the slope of line AB? Simply with perpendicular upon base. Perpendicular upon base. For that, we will be just forming the perpendicular and base, and how we are going to do it? We will take the perpendicular from this point C on the x axis. We will take the perpendicular from this point B, right. Let us say this point is, let us mark it D. We will also take a corresponding perpendicular on the y axis. So, now we are getting our triangle, the triangle BCD. This is our triangle in which BC is the slope or the hypotenuse, CD is equal to the perpendicular, and BD, as we can see, will be the base part. Now, if I write perpendicular upon base, this can be written as per this particular figure, it can be written as CD upon BD. Now, if I correspond to the values, let us say the C is corresponding to 25, which is taken to be V2, D is corresponding to value 10, which is taken to be V1. We know that this is calculated by V2 minus V1 divided by T2 minus T1. V2 part, we say that this is 25 minus V1 part, from B we are calculating, it corresponds to 10 divided by, when I talk about time, this D corresponds to the value 40, which is taken as T2, and B corresponds to value 20 seconds, which is taken as T1. This comes out to be T2 minus T1, means 40 minus 20. Now, this can be represented as 15 by 20, right. So, this comes out to be, the value is 15 by 20 meter per second square, or I can relate it to be what? 0.75 meter per second square. This is the acceleration. So, now you have seen how to calculate acceleration graphically. Simply slope of the line, whatever line is accelerated, showing accelerated motion, then perpendicular upon base. And by perpendicular upon base, I mean to say we need to construct taking the perpendiculars on the x axis as well as y axis, and then we need to relate what exactly are the figures they are corresponding to, and then we will say that calculate acceleration with V2 minus V1 divided by T2 minus T1, where V2 minus V1 corresponds to the perpendicular or the change in velocity, and T2 minus T1 corresponds to the time or the change in time. Got it? So, this is the first thing that we will be calculating through graphs, that is acceleration.